So for part C, hopefully you're kind of getting the idea. Part B basically made a formula for us to use. So I don't want you to memorize that. I want you to just understand that an integral like this with that variable in the upper limit builds an antiderivative. That's the key part. Memorize that. Excuse my yawns. That's what happens. I keep making early morning videos. So for part C, we're taking the function 5 to the negative x cubed plus 2. We're integrating, subbing in t. So we're getting the antiderivative of that function with respect to t. And then we take the derivative. So if you get your construction theorem, this is another one where you should just be able to say the answer should be 5 to the negative t cubed plus 2. So there's a variable swap, but otherwise I took the antiderivative, I took the derivative, I'm back where I started. This is an interesting one. It starts to make more sense why we would want a construction theorem here, because if I wanted to try and walk through this step by step, the first step shows how that's not so easy because I don't know the antiderivative of 5 to the negative x cubed plus 2. So we could still walk through the thought process that we used above, but we can't really write down the function and walk through step by step. So it would be, we'd basically be doing what we see up here. Step number 1, find the antiderivative. I don't know what that is, other than to say that it's this. This is the antiderivative. We would then take whatever that is, and we would plug in a, and we would, what is our a? We would plug in -3 for a, and we would plug in t for our top limit. So this would still be an f of x for us. I actually flip-flop the variables on this one. So we'd find our f of x, we'd plug in -3, we'd plug in t, so this would be a t, and this would be a -3. And then we'd take the derivative. The derivative of f of t would get us back to little f of t, which is our 5 to the negative t cubed plus 2. And the derivative of big F of -3 is just going to be, 0. So that's just going to drop out for us. Okay, part D. So in part D, we want the derivative with respect to p of the integral from 7 to p of tangent of the square root of y dy. So again, we don't have anything too weird happening. We're saying find an antiderivative, a specific antiderivative of tangent of the square root of y. And then take the derivative of the antiderivative of tangent of the square root of y, except we've now switched our variables and made them p's. So what we should get back is the tangent of the square root of p.